We're going to continue on with the note sheets for P.2. Negative square root of 40 minus 9x plus 2 equals x. Now we need to get the radical by itself since there's only one of them. So the first thing we can do, subtract 2 from both sides, which will tell us negative square root of 40 minus 9x equals x minus 2. Now at this point here, we do need the radical to be positive. So we can multiply by -1. We can divide everything by -1. Either way, it's going to do the same thing. So if we multiply our radical, the negative square root, by -1, we get the square root of 40 minus 9x is equal to, here we're going to distribute that negative. So the x is going to go from positive to negative, and the 2 is going to go from negative to positive. It is the radical by itself. Yep. So now we're going to put both sides to the nth power. Nth power in our case is 2. So on the left-hand side, the square root and square would cancel, telling us 40 minus 9x is equal to our negative x plus 2 times negative x plus 2. I think that's the middle school bill.
Why are they hooked to the high school? Middle school or in the high school?
Probably. I think the bells were a little more lined up last year. Or, yeah, I don't know. Now the left-hand side is going to stay 40 minus 9x for a good little bit until we can simplify the right-hand side. Now the first thing we can do is negative x times negative x. Well, negative times a negative is a x times x. X times 2, negative x times 2 is negative 2x. 2 times negative x. Yeah, negative 2x. And 2 times 2 is? So we combine like terms, we get x squared minus 4x plus 4. So 40 minus 9x is equal to x squared minus 4x plus 4. Since we do have a quadratic, we need to get this thing equal to 0. So the first thing we can do is subtract 40 from both sides and add 9x. 0 is equal to x squared minus 5x minus 36. Now this one here is indeed factorable. There is no greatest common factor between the three terms. One of the kind of giveaways that there's not a greatest common factor is because the number in front of x squared is 1. And there is not a variable in common with all three. So we'll have 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite, positive and negative. Our factors of x squared are x and x. Now our factors of 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. Okay. Don't want that. Which set of 4 and 9? Which one goes where? 4 with the plus, 9 with the negative. Before we move on, we do need to check and make sure we do have the correct middle term. X times negative 9 would be negative 9x. 4 times x would be plus 4x, giving us negative 5x. Now, since we have two things multiplied together equals 0, one of them must be 0. And lastly, all we need to do is solve for the value of x. So if x is equal to -4, x is equal to 9. Questions on this here? Now, it'd be good to check and make sure, so we have -4 and 9. So let's try -4 first. Negative square root of 40 minus 9 times -4 plus 2 is equal to -4. Now at this point here, if we wanted to type the entire left side in, we could. If we do this by hand, our -9 times -4 is going to be plus 36, giving us negative square root of 76 plus 2 equals -4. Now our negative second square root of 76 is 2 squared of 19. Yeah. 9 times -4. Well, those aren't equal at all. Yeah. So -4 actually does not work. And we can try this again with 9. Negative square root 40 minus 9 times 9 plus 2 is equal to 9. That's not going to work either. Probably no solution. Because the issue comes it would be, and the additional answers in the back. P point. Let's put this organized. Okay, why in the heck? Cancel these things. Answers to exam. Exam. Yeah. Exam. Yeah, because the issue is why would they put in that solution? Point.
Oh, it's that one thing that's like this, like, say, it's like.
Yeah, negative 49. Oh. It would be because. All right. Let's look at it graphically. Let's see this here. Y equals. Figure all this out. Second. No. Negative second square root 40 minus 9x plus 2. Ah, okay. Knew there was something wrong. What is that? Took me a minute to find it. No. So I circled a spot on this here. Yeah, negative 4x plus 9x is what?
It's 5.
So it should be almost at the bottom. So right before we factored, yeah, so it should have been 5x instead of negative 5x, which means we do need to flip the signs. All right, guys. Let's focus back in. So we needed to switch the signs because our negative 4x plus 9x should have been positive 5x, not negative, which threw everything off. Now, for the most part, it's not really going to change anything besides the fact that we have x plus 4 and x minus 9. So that's plus. Yep. So it should be x minus 4 and x plus 9, because our x times 9 would give us positive 9x. Our negative 4 times x would give us negative 4x, giving us the positive 5x that we wanted. Now when we solve this here, we'd have x minus 4 equals 0, and x plus 9 equal to 0. So for our negative 4, we would add 4 to both sides. Minus x is equal to 4. So it should have been positive 4 and negative 9 as our two solutions. Now at this point here, we could go back and check our positive 4 and negative 9. So if we check this here, negative square root of 40 minus 9 times negative 9 plus 2 is equal to negative 9. Our negative 9 times negative 9 is going to be plus 81. Here we'd get the square root of 121. All right, guys, let's focus in. Our square root of 121 would be 11. And negative 11 plus 2 would be negative 9. So we do get the correct answer. So negative 9 does work. We can do the same thing with positive 4. Now 40 minus, so negative 9 times 4 is going to be negative 36. 40 minus 36 is going to be positive 4. Square root of 4 is 2. And negative 2 plus 2 is 0. So positive 4 doesn't work, but negative 9 does. Good.
When it starts out, it's like all black, and it's
The thermal heat,
yeah.
Did you have one like that?
someone did have one that brought it in, but it's interesting concept that you have to use heat to actually get the color back. Because otherwise it doesn't. It all looks the same. Questions on this here? Okay. Yep. So whenever we do the radicals, I realize we didn't do them on the previous ones, but we do need to check them. We need to plug them back in and check them. So, because if we look back at the previous two, I realize we didn't do that yesterday. Here, for our solutions that we got was x is equal to 3, and I believe x is equal to 7. And if we check these now, 2 times 3 minus 5 minus 3 minus 3 is equal to 1. Now at this point here, especially for the homework, you can type this into the calculator. You don't have to do this by hand. So we can pull the calculator up, say second square root of 2 times 3 minus 5 minus second square root of 3 minus 3 is 1. So 1 does indeed equal to 1. It works. And we do the same thing for 7. 2 times 7 minus 5 minus. And again, we can check it in the calculator. Second square root 2 times 7 minus 5 minus second square root 7 minus 3, which does equal 1. So both of those work. So it is good to go back and check and make sure that our solutions do work. And especially if we're talking about radicals and are squaring both sides, we will need to check those. Solve an equation involving a rational exponent. Now there's different ways we could go about solving this and working with this. One of those involves the fact that we're using or changing this into radical form. Because our properties of rational exponents, a to the n over m, is equal to the nth root of a to the n. The number on bottom is our index of the radical we're using. The number on top is the exponent attached to it. So when we look at this left side, this x minus 4 to the 2/3, what we're really saying is that we have the third root of x minus 4 squared is equal to 25. And we could solve it this way here. And since we do have a radical, the first thing we're going to do is put both sides to the nth power. Well, what power would we put both sides to? 3. Since we have a cubed root, we're going to put both sides to the third power because our cubed root and third power would cancel, telling us that we have x minus 4 squared. And on the other side, we have 25 to the third, which is 15,625. Questions on this so far? Now at this point here, we do have a single term being squared, and that's the only place where x is. So now we can use the square root method. We can take the square root of both sides. On the left side, the square root and square would cancel, telling us that x minus 4 is equal to, plus or minus, we have to take the square root of 15,625. And hopefully, it comes out to be a nice number. 125. So x minus 4 is equal to positive or negative 125. Last thing we need to do to get x by itself is to add 4 to both sides, telling us x is equal to 4 plus or minus 125. Can we add 4 to 125?
Yes. Oh, what? So you get 2 x's?
So we can add 4 in 125, and we can subtract 4 in 125. Well, 4 plus 125 is 129. And 4 minus 125 is negative 121. Questions on how we got these two solutions here? All right. 129. Now we can plug these back in and check and make sure that they work. So we say 129 minus 4 to the 2/3 should equal 25. Parentheses 129 minus 4 to the 2/3 is indeed 25. All right, guys. Laren, we wait. 25 is equal to 25, so that checks out. Now we are going to do the same thing with negative 121 also. So negative 121 minus 4 to the 2/3. And we should get 25. So this is also 25 equals 25. So both of these are our solutions because they do give us the same result. Questions on this here? Now the last type that we're going to look at is absolute value equations. Now absolute value equations are a little bit, not tricky, but there are some steps to it. Because the first thing we need to do with solving an absolute value equation is get the absolute values by themselves. So here, the absolute value is already by itself. So we didn't have to add, subtract, multiply, divide, do anything to get it by itself. But once we get it here, we have to set whatever's inside the absolute values equal to the other side when it is positive and when it is negative. Now the absolute value of x minus 2 will not equal positive negative 3, but what's inside the absolute value, that x minus 2, could be positive 3 or negative 3. Because the absolute values will turn it from positive, keep it positive, or turn it from negative to back to being positive. So the x minus 2 inside the absolute values, this here could be positive 3, or what's inside here could be negative 3. And once we split this apart, we're just going to solve for x. So on the left one, we can add 2 to both sides, telling us that x is equal to 5. And for the other one, we can add 2 to both sides, telling us x is equal to -1. So when x is 5 and x is -1, we will get a solution. And if we check this here with 5, the absolute value of 5 minus 2, to see if it is indeed equal to 3. Well, our 5 minus 2 is 3. Absolute value of 3 is 3, so we do have a true solution. We also have -1. Well, our -1 minus 2 is -3. Absolute value of -3 is 3. So we do have another true solution. So -1 and 5 work. For pretty much all these absolute values, we're going to have more than one solution for this here. The only way we won't is if the v of the absolute value is the only point that hits the x-axis, or if it doesn't cross it at all. We wouldn't have any solution. Questions on this here? Yes. Yes. So the next one here, we have the absolute value of x squared minus 3x is equal to -4x plus 6. So again, doesn't matter the setup, we need the absolute value bars, the absolute value expression by itself. And here it is indeed by itself. And one of the things that this is saying is it's saying what's inside the absolute value. Our x squared minus 3x is indeed equal to -4x plus 6. It's equal to the positive case of the other side. And the x squared minus 3x is also equal to the negative case of the other side. So we're not just switching one term, we're switching the whole expression, because what's inside the absolute value can equal the positive of the other side or the negative of the other side. We're used to it being a single number, but we can have an expression. Now we can look at the left one first. Our x squared minus 3x is equal to -4x plus 6. Since we do have an x squared term, we need to get this equal to 0. So we can add 4x to both sides. And we can also subtract 6. Now the right-hand side is going to become 0. The left-hand side will have x squared. Our -3x plus 4x is going to be plus x. Now, since there is no like term on the left-hand side for our -6 or minus 6, it's just going to stay minus 6. So we have x squared plus x minus 6. Now we can graph this or factor it. Either one works. Now if we factor it, we'll have 2 sets of parentheses with 3 spaces. Since our 6 is negative, our signs are opposite. Now our factors of x squared are x and x. Factors of 6 are 1 and 6 or 2 and 3. So we'll take 2 and 3. We'll make the 3 positive and 2 negative. Now if we check this here to make sure we do have the correct middle term, x times -2 would be -2x. 3 times x would be plus 3x, giving us a positive 1x, which is our middle term. At this point here, we have 2 or more things multiplied together to equal 0. So one of them must be 0. Either x plus 3 is equal to 0 or x minus 2. Now with our x plus 3, we would minus 3 from both sides, telling us x is equal to -3. Our next one, we would add 2 to both sides, telling us x is equal to positive 2. And those are 2 of our possible solutions. We will need to check these in the end. Now we have the other side. Now before we can start adding or subtracting things from both sides, we will have to apply the negative to both terms. Our -4x is going to be positive 4x. When we apply the negative to positive 6, we get -6. And now that we've applied that negative to both terms, we can get this equal to 0. So the first thing we can do is subtract 4x. We can also add 6, telling us that we have x squared minus 7x plus 6 is equal to 0. We could factor this or graph it. I'm going to go on and factor it. There is no greatest common factor between the three terms. And if we look at our signs, since the third term is positive, the signs are the same and match the sign in the middle term. We'd have negative and negative. Our factors of x squared are x and x. Factors of 6 are going to be 1 and 6 or 2 and 3. The ones we'll want for this one here are going to be 1 and 6. And if we check this to make sure, x times negative 6 would be negative 6x. Negative 1 times x would be negative x, giving us a negative 7x. Now, just like the other one, since we have two or more things multiplied together to equal 0, one of them must be 0. So either x minus 1 is 0 or x minus 6. And lastly, in solving for x, we would add 1 to both sides, telling us x is equal to 1. Here we would add 6 to both sides, telling us x is equal to 6. So we have 4 solutions. We have that x is equal to 1, 6, 2, and negative 3. Questions on how we got these 4 solutions? Which one of these do we want to check first? 1. So we value 1 squared minus 3 times 1 is equal to negative 4 times 1 plus 6. At this point here, the yellow calculator doesn't do absolute values. I'll show you how to do it on the graphing calculator here in a minute. But if we do this by hand, the right-hand side, negative 4 times 1 would be negative 4. Negative 4 plus 6 is 2. The left-hand side, we have negative, or 1 squared, which is going to be 1. Negative 3 times 1 is negative 3. Our 1 minus 3 is negative 2. Take the absolute value of negative 2, we get 2. So 2 is indeed equal to 2. We can check 2 next. So we'd have the absolute value of 2 squared minus 3 times 2 is equal to negative 4 times 2 plus 6. Again, let's look at the right side first. Negative 4 times 2 is negative 8. Negative 8 plus 6 is negative 2. We haven't finished this one here, but we can already say 2 is not going to work, because there's no way for a negative number to come out of an absolute value. Now, if we go on and check this here, 2 squared is going to be 4. Negative 3 times 2 is going to be negative 6. Our 4 minus 6 is going to be negative 2. Now, we do have a negative 2, but we have to take the absolute value of it. The absolute value of negative 2 is 2. And our 2 is not equal to negative 2. Do we see why that happens? Yes. And it's kind of, the only reason it does that is the first one, we did have that change from negative to positive. The second one, there was nothing on the right side to adjust that negative 2. All right. Now we need to do the same thing with 6. And negative 3. if y'all were to pick one of these to not work, which one would you think it would be, 6 or negative 3? Negative 3. Let's do it first. So on the right-hand side, negative 4 times negative 3 is 12. 12 plus 6 is 18. That's not bad. On the right-hand side, absolute value, negative 3 squared is going to be 9. Negative 3 times negative 3 is going to be plus 9. 9 plus 9 is 18. Absolute value of 18 is, okay. Kind of went counterintuitive to our thought, wasn't it? Because we think the negative is the one that doesn't working, and it does. Let's check 6. I'll do the absolute value side first. 6 squared is 36. Negative 3 times 6, negative 18. 36 minus 18 is 18. And the absolute value of 18 is, well, 18. On the right-hand side, negative 4 times 6 is negative 24. Negative 24 plus 6 is negative 18. Does not work. So 1 and negative 3 are our two solutions. Now on the graphing calculator, math and over 1. If we click the math button and go over 1, the first option is actually an absolute value. So we could have done 6 squared minus 3 times 6 and see that it got us 18. And then done negative 4 times 6 plus, what is it, 6? Negative 18, they don't work. So it's another way we can check this here. All right. We'll finish this up tomorrow, and then you'll have the rest of the class time tomorrow to work on these here.